Hello everyone. So today we will be talking about hoisting and closures. Both of these behaviors come straight out of how execution context work. Hoisting shows up in the memory creation phase, wherever closures are the functions remembering the scope they were born in. So let's start with hoisting. Hoisting is the reason you can use a variable or function before the line you wrote it. Nothing physically moves in your file, it's just the memory creation phase at work. JavaScript reserves memory for every variable and function before running any code. So the names already exist when execution starts. In this example, the call comes first, but greet was already stored whole during the memory creation, and we get our output as hello. Functions are stored complete, but variables are not. A var is reserved and set to undefined until its assignment line runs. The first log doesn't crash because x exists, but it has not been assigned yet, so it reads undefined. Only the declaration is hosted, never the value. And during the memory creation phase, x is undefined. If we run this program, the first we will get undefined, and after assignment we will get the value as 10. Let and const are also hoisted, but they behave completely different. They are not given any starting value, and touching them before their declaration throws an error. In this example, we are trying to access the a variable before it was declared, so it will throw an error. You cannot access a before initialization. But in case of var, we were able to do that. The window between the top of the scope and assignment line is temporal dead zone. The variable exists in memory, but reaching it there is off limits. Before a was declared, it was in the temporal dead zone, which means that it exists, but we cannot use them. But after the declaration, everything works as expected. So var are hosted and start with undefined. But for the case of let and const, they are hosted but are in the temporal dead zone and cannot be used until they are declared. And functions are completely hosted, which means they are usable before definition. So next topic we have is closures. Before closures make sense, here is the key idea. A function defined inside another function can use the outer function's variable. This access is called scope. In this example, inner never declared message, but it can read it because inner lives inside outer and it has access to outer's variable. Now, what if outer return inner instead of calling it? Normally, a function's variable disappear once it finishes, so you'd expect counter to vanish along with outer. But it doesn't. Each call to counter picks up right where the last one left off. This works because inner does not just use count, it hold on to it. When a function is returned and used later, it carries the outer variable it depends on along with it. That combination of function and the variables it remember is a closure. In this example, count does not reset on each call and no outside code can reach it directly. It stays alive privately inside the closure, reachable only through inner. Together, hoisting and closure explain a lot of JavaScript that otherwise looks surprising. So this is it for this video. Thank you for watching.